Here I would like to show you how to drive the I2C temperature sensor from TI. The part number is TMP108 with our NanoBeacon configuration tool and our development kit. So in order to do that, so right now we have the evaluation kit wired through I2C bus to our development kit, and I would like to give you some background information on the system design, how we want to achieve the lowest power possible through our unique configuration. Here is the diagram. You can see normally in order for us to drive the I2C sensor, so we initialize the sensor and delay for some time for the conversion and the read, and then go to sleep and just repeat this pattern. That's a regular way of driving this temperature sensor. But here today I would like to show you another way to reduce the system power, which is this. Okay, you can see the first cold boot is similar to the conventional way, right? So initialization, wait to convert, and read the temperature sensor data. And then we do differently from the conventional way is we ask the sensor to convert again, because the conversion of the temperature sensor takes 30 milliseconds around. That range is very long. During that time, we don't want to keep the 100 device, which is our NanoBeacon SoC, to be awake. So instead of doing that, we want to ask TI sensor to convert again before we enter into sleep mode. Okay, in that sense, the next time when we wake up, there is already a TI temperature sensor stored in the memory. We can simply just read out from the TI sensor and then send another conversion command and enter sleep. So in that sense, you can see the system sleep power, system power-wise, can be greatly reduced, because our device is gonna sleep longer time most of the time, and only take the TI sensor in the majority of the power consumption in the system design. So this is how we're gonna achieve the low power from system design perspective. And the next step, I'm gonna show you how to configure through our NanoBeacon configuration tool. And now we open the NanoBeacon Config Tool. So first of all, we need to enable the I2C slave number 1 and check the pin of the clock and the data, right? And then we need to put a slave address, which is 40A for TI temperature sensor, and then click the I2C command. We need to input all the commands through this tab. So first of all, we need to do the cold boot initialization of the temperature sensor, and we're gonna look at a data sheet and find out what bytes need to be put in. There should be 3 bytes of register settings need to be written into the TI temperature sensor, which is 01, 22, and 10 in hex. And this is for the cold boot initialization, so this box has to be checked, and then click add. So the initialization command will be showing here in the command window. And the next, we need to do the delay command. For the TI sensor specifically, we need to do 30 millisecond delay, right? So for the conversion, so the delay, the maximum delay in our GUI, we support maximum 10 milliseconds. So in this case, we have to input 3 times of the delay command in order to make a 30 millisecond delay. 1, 2, 3, okay. And the next, we need to initiate conversion command. Right?
No, this is make the point.
Oh, sorry. So we need to go point the pointer to the address where we need to read the temperature sensor data from. So that's what is the address? 00, right? So we put a 00 there. We need to read from 0, address 0, in order to get the temperature sensor data from that address. And please note, so this reading, this writing we have to do for both cold boot and the warm boot. So we need to check both boxes. Add, okay. So next, we start to read, okay. It's in 2 bytes. So add, okay. Read successful. And next, as I explained earlier, in order to save the power, so we have to do the conversion before our device enter into sleep mode. So that's why we need to put another write to the command set. Okay, that's done. Okay, so that's simply went through all the process of configuring the I2C command for the TMP108 sensor. Now we have successfully configured the I2C sensor for TMP108 sensor. So now let's try. First of all, let's put a note. We don't support I2C sensor run in RAM mode. Unfortunately, you have to do the eFuse programming before you try this out. We already burned the eFuse of the device with the configuration file we just configured. Now let's use the sniffer to see if we can broadcast out this sensor information. And now let's run a test, temperature sensor test. We're going to use the heat gun to give some heat to the TI temperature sensor. Where's our NanoBeacon device? Oh, it's right there. Okay, and NanoBeacon gonna send out the temperature measurement data in real time. Now you can see it's a 3E70. 4C50 is changing. Let's see how high we can go.
What's the number?
70.
70 is already more than 100 degrees. This is a hex.
7F0.
Oh, this is already maximum.
That's the max. That's the max. We already reached the max of TI sensor.
128.